production technique that transformed nations and transfixed the world. Now, the unrelenting pace and prolific production of assembly lines on Modern Marvels.
I think the assembly line is the most significant technological development of the 20th century. Nearly everything that we use, we would not have it in the quantities we have it and at the prices we have it without the assembly line.
The assembly line moves the world. It is the driving force behind every industrial nation on Earth. Workers and machines organized in a continuous flow of raw materials made into products on an unimaginable scale. This method of work in motion is known as progressive production.
Work moves to the person and moves past the person rather than the person going to the work.
Each individual has their responsibility for taking care in a certain segment of time so that the line will run smoothly. We try to work as teams so that everybody will know what the other one's doing to keep it running smoothly.
Work in motion is as mesmerizing today as it was at the turn of the 20th century. What may look like miles of mechanized mayhem is actually one of the most dependable and durable production techniques ever invented. Consider this. One factory, the Hyundai Motor Manufacturing Plant in Montgomery, Alabama, has the ability to produce 300,000 automobiles per year. That's 1,000 cars a day. Formless coils of steel enter the assembly line and emerge as cars. Along the way, there's a whole lot of stamping, welding, painting, and of course, assembling. But the key is to keep the entire operation moving. Hyundai's ultra-high-tech assembly line reflects the same audacity of scale found in the technique's origins. From the very beginning, the assembly line was first and foremost about the need for speed.
Industrial society was highly advanced at the time the assembly line came into being, but once it came into being, it was so productive that very few things were made without the line after that. There are several factors that went into the making of the assembly line. The first had to be that the parts of any product that would be made on an assembly line had to be interchangeable.
Interchangeable or uniform parts were first invented in 1813 by Connecticut gunmaker Simeon North for his pistol, and later refined in the manufacture of firearms. Uniform parts and the simplicity of attaching them to each other was a pivotal innovation in the history of mass assembly. The primary inspiration for putting work in motion originated in the 19th century disassembly lines of Cincinnati meatpacking facilities.
The idea being that a cow or a pig was grabbed up by the hind legs and essentially put on a moving line and was successfully slaughtered, gutted, and then butchered, all on a moving line basis.
In the 1850s, simple conveyors developed by textile manufacturers were used to move heavy molds filled with hot iron in the production of steel. Several decades later, can manufacturers created an elaborate system of conveyors designed to move specific work to specific workers on an assembly line basis.
And there in can making, you have various machines that are linked together by conveyors, which cans are taken from sheet steel and built up into full cans.
Henry Ford, who built his first car in 1896, was unique among automobile inventors, not only because he sought to build a car for the masses, but because he wanted to build one that was the lowest priced. It wasn't until he developed the wildly successful Model T that Ford began experimenting with available production techniques. By 1908, the nation was on the move, and Ford's need for production speed was paramount.
You have to understand the context in which the assembly line took place at Ford. From the time that the Model T was introduced, the Ford Motor Company could not meet the demand for Model Ts.
And his goal was never to create the assembly line. His goal was to constantly improve production to drive the price of his car down, but also keep the quality up and keep the production volume going up. And he pursued this goal relentlessly.
Ford regularly rearranged men and machines to improve the speed of stationary component assembly. In 1910, Ford opened the 60-acre Highland Park plant and set up the machinery on the shop floor in the actual sequence of automobile production. This radical departure from the more conventional grouping of machines by type enabled workers to deliver parts more efficiently to each sub-assembly station.
He was averaging a doubling of production for several years before the assembly line. But this relentless drive for ever more production at ever lower cost led him almost inexorably to the techniques that eventually developed into the assembly line.
Ford then made the giant step of moving the car instead of the worker, based on the principles of Frederick "Speedy" Taylor. As the first authority in industrial efficiency, Taylor's work was already popular in the steel industry.
It was his specific understanding that human intelligence, as applied by workers at the point of production, was a hindrance to efficient operations.
The principles were designed to break down a particular job into smaller and smaller tasks, which meant that much of the task could be controlled, mechanized, and thus speeded up. This process would require more men with less skills.
Effectively, he tailorized the work and took the skill out of the work process, dividing the labor, subdividing it again, so that a workman would do a smaller and smaller part of it. And doing the smaller and smaller piece of work, he could do it faster and faster.
In April of 1913, 29 highly skilled Ford employees stood next to each other alongside a component sub-assembly line. The line was composed of all the parts necessary to make a flywheel magneto. Rather than assemble the entire component by himself, each man performed a simple, narrowly defined task on the component and then passed the part on to the next guy.
Then they said that if this works with transmissions or it works with magnetos, what about engines? What about front axles? What about rear axles? And eventually they got all these sub-assemblies on the assembly line.
1 year later, after Ford had successfully assembled key car components on an assembly line basis, a Model T chassis was pulled by rope across the factory floor. Workers began picking up parts from carefully placed piles of sub-assembly parts and attaching them. When they were finished, they had assembled an entire car in only 5 hours and 50 minutes. The moving assembly line had cut the production time of the Model T in half.
Ford and Ford's engineers took all these ideas and brought them all together and created what we think of as the modern assembly line, but it was really an amalgam of all sorts of other ideas, but nobody had ever tried to put them all together and use them to put together something as complicated as an automobile.
Fashioned after the conveyor belts used in slaughterhouses, Ford installed the first automatic conveyor belt to move the chassis down the line in a continuous flow. What used to take a man 728 hours to build could now be built on a moving assembly line in 90 minutes. Production soared dramatically from 82,000 cars in 1912 to a staggering 267,000 cars in 1914. With that, Ford dropped the price of the average Model T from $600 to $490.
The assembly line created for consumers a kind of abundance that the world had never seen before.
Next up, Henry Ford picks up the pace. Hyundai's new Montgomery, Alabama plant, which employs nearly 2,800 workers, was built at a cost of $1.1 billion.